Day 26, Honors Physics, Problem 32. Once again, like all these uniform acceleration problems, it tells you this is uniformly accelerating up here. You draw a basic diagram, and this one really is pretty basic. And then your conditions, set your initial conditions for your 5 variables. In this case, v sub I is 0 meters per second. We're looking for v sub f. A is 3 meters per second squared, and t is 13 seconds. Set those up and then find the appropriate equation or equations, and sometimes you have options. But I think in this case, if you do that first equation that we have listed, v sub f equals v sub I plus at, we will get, well, v sub I is 0 plus 3 times 13. So our v final is 39 meters per second. In this case, it seems low, but it's over 80 miles per hour, right closer to 90 miles per hour. Anyways, that's our v final. But we also need to do, in order to transfer over to part B, we need to figure out S, as you'll see here in a second. And I can use the third equation for that. S equals v sub I t plus 1/2 a t squared. So S will equal 0. I'll just skip that part because that's 0. Times 1/2 times 3 times 13 squared. So my S for part A here is, I believe, 254 meters, going to 3 sig figs. That's important because in part B, we got to figure out how much time it takes to do the quarter mile. Now we also need to convert. A quarter mile, as you might know from track and field, is roughly 400 meters. The one time around a track, a standard track, is 400 meters. We call that the quarter mile. But if you want to be a little bit more particular, 1 mile's 402 meters, I believe. You can double check me on that. But in part B now, we're not accelerating anymore. We've gotten up to our top speed of 39 meters per second in a time of 13 seconds, and we've traveled 254 meters. So now we can only stay at our 39 meters per second. For the final part of the problem, or the remainder of the time now, we just have v equals d over t or s over t. You can't increase your speed anymore. In other words, you have 39 equals, but our distance is not 254. It's 402 minus 254, which is 148 meters. We have 148 meters to go. And we can now calculate, I'll call that t sub 2. That's the time at which you spend going the top speed of whatever it is, around 90 miles per hour. You get that answer, then add 13 seconds on for the time it took you to accelerate up to speed, and that will get you for the total time for the quarter mile from rest. Obviously, this is not a race car. This is probably a standard to substandard van or small commuter car.